Alright, so today is a continuation of yesterday's topic, solving by the quadratic formula. The only difference is the discriminant, the value that you get underneath the radical. Yesterday, all of the answers for the discriminant were positive, so you had two real solutions. Today, you're going to have negative discriminants, which are going to lead you to have imaginary solutions, and we've done those earlier in the chapter. So that's going to be where you have I as your answer. All right, so we're going to solve just like we did yesterday. If it's already equal to 0, you label A, B, and C. If it's not equal to 0, you have to add or subtract to move everything to one side. So in this case, now we have A, B, and C. All right, so we're going to substitute in our quadratic formula, which is listed above. So it's x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So if you need to use your calculator, remember just do the discriminant without the square root. So that gives me square root of negative 23. Now you won't be able to take the square root of negative 23. You can if you are in a plus bi mode. So that gives me something that's not simplified, or it's not a whole number. And then see if there's a perfect square that goes into 23. 23 is not divisible by 9. It's not divisible by 16. It's not divisible by 4. So since we ran out of perfect squares to try, you just have the I on the outside, because this is like square root of negative 1 times 23. So it's plus or minus I root 23 over 8. All right, problem number 2. We have A, B, and C already labeled, so it's opposite of B plus or minus the square root of B squared minus 4AC all over 2A. So 2 times 3 is 6, and now I just need to figure out what this is. So negative 1 squared minus 4 times 3 times 8, and that gives me negative 95. And just like the last one, there's no perfect square that goes into negative 95, so it's 1 plus or minus I root 95 over 6. All right, flip over to the other side. So first thing you should do is, it's already equal to 0, so we can say A, B, and C. In this problem, we need to add 6x to the other side. Make sure you realize that the 6x goes in the middle here, and then the 12. Okay, so now we know A, B, and C. All right, so now we're going to do x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then I don't know what the discriminant is, so if I do that, I get negative 8. All right, so this one does have something that, it doesn't give me a whole number. It's not a perfect square, but 8 can be divided by 4. So I can say that this is the same as negative 1 times 4 times 2, right? Which would be, so we have negative 12 plus or minus, we'd have I. This would be a 2, so 2I root 2 over 2. And then just like yesterday, you look at all the numbers that are not the ones in the radical and see if you can reduce them all by the same number. Since they can all be divided by 2, we have negative 6 plus or minus I root 2 over 2. All right, and then the last problem, we have negative b plus or minus b squared minus 4 times a times c all over 2a. So we have negative 6 plus or minus, and I have to figure out what this is. So we have 6 squared minus 4 times 1 times 12, which is negative 12, and this is 2. All right, so negative 12, you could try taking the square root of that. It's not a perfect square, but 12 is divisible by 4, so this could be negative 1 times 4 times 3, should be I and 2. So this is negative 6 plus or minus 2I root 3 over 2. And then again, just like we did yesterday, look for a number that can divide all those numbers except for the 3. And we can divide them all by 2. So it's negative 3 plus or minus I root 3 over 1. But we don't really need to say that, so negative 3 plus or minus I root 3. You don't have to say over 1. And then we're all done.